Hey everybody, today we're going to talk about ions. We're doing the ion worksheet. This is a rather long worksheet, so I just want to get started. One of the things I did not do on this worksheet is I did not put the atomic number down here for any of the atoms, and that was intentional because I want you to get used to looking for the atoms on the periodic table. So when I look at chlorine, chlorine is number 17. So let me just find these first. Sulfur is number 16. Sodium is number 11, beryllium is number 4, nitrogen is number 7, and magnesium is number 12. So you should be able to find those on your periodic table. Now remember that your atomic number is the same as the number of protons, and that is always true. Now, in the case of balanced atoms, the number of protons, which are positive, is identical to the number of electrons, which are negative, because it is a balanced atom and it is on the periodic table. So that means that the number of electrons is always the same as the number of protons. Now over here on the right, what we're doing is we're creating ions. Now remember, what an ion is something that is charged. Alright, so our protons and our electrons are not the same. But remember, your protons are always determined by your atomic number, no matter what. You can never, ever, ever mess with protons. So for chlorine, I have 7 protons. But you'll notice I have a negative charge, which means I have to have an extra negative charge. I have to have one more negative charge than I have positive charge. So since I can't change the positive charge, I have to go and change a negative charge. Now in the case of sulfur, sulfur we know is number 16, so that means it has 16 protons, but it also has to have 18 electrons. It has to have 2 more this time. 2 more electrons than it has protons. Sodium is number 11 on the periodic table, which means it has to have 11 protons, but you'll notice up here it has a positive charge. Well, I can't change my positive number of protons, so the only thing I can do is take away an electron and make it go down to 10. Beryllium is number 4, so that means it has 4 protons, and it has a 2 positive charge. So that means we have 2 less electrons than we have protons, because we have to have 2 more positives than we have negatives. Nitrogen is number 7, so it has 7 protons, and in this case it has 3 more electrons because it has a 3 negative charge, so it has to have 10 electrons. And finally, magnesium has a +2 charge, so it has to have 12 protons, has to have 2 more protons and has electrons, so it only has 10. Alright, now guys, if you're doing this, watching this, I would suggest you stop watching right now, pause the video, and go off and do the rest of the worksheet on your own as much as you can, and then come back and keep checking. Starting with this page, I'm not going to bother writing the number up here. Potassium is number 19, but I'm not going to bother writing that there anymore for anything below it. I'm just going to say that it has 19 protons. Alright, and because my positive protons and my negative electrons have to be identical for a balanced atom, there are going to be 19 on both sides. Now phosphorus is number 15. Oxygen is number 8. Iron, and notice I've got 2 of them right below one another. They're all 26s. And copper is number 29. Now you'll notice over here on the right, these are all ions, and they're all ions of the same things that we have on the left. So I'm just going to write down 19, 15, 8, 26, 26, and 29. Why? Because the number of protons can never, ever, ever change. So it doesn't matter that it's an ion or whether it's an ion or an isotope, that still has to stay the same. Now the difference is we can always mess with the number of electrons. Remember, your protons are positive, your electrons are negative, and here we have to have more positives, so we're short 1 electron. Here we have extra electrons. Here we have extra electrons, 2 of them. Here we have too few electrons by 2, and here we have too few electrons by 3. So we're short 3 electrons there. Copper short 1 electron, so that's going to be 28 electrons. We have more positives than negatives. So if you look at these, you'll notice here I have 1 more positive than negative. Here I've got 3 more positives than negatives. Here I've got 2 more positives than negatives, etc. So you should be able to see that. Alright, let's let's keep going. Again, we just did copper. Copper was number 29. If I look up lead, it's number 82. And it has to have a balanced number of protons and a balanced number of electrons. And remember that our atomic number tells us how many protons and how many electrons it is going to have. Antimony, which doesn't look at all like Sb, but that's what its name is, antimony has 51. Now again, our number of protons can't change, so copper still has 29 protons, but here I have a 2 plus charge, so I have 2 more protons and electrons, so I'm short. Let's try that again. I have 27, okay, because I'm short 2. Right, now lead has 82 protons, that's always true. But here I'm short 2 electrons because I have more positives. So I've only got 80. Here I'm short 4, so that's a 78. How about antimony? Antimony, if I look it up, is number 51. And here I am short, again, all these are positives. I'm short 3 electrons, so I've only got 48 here. And here I'm short 5, which is 46. All right. Now these are a little bit different. Here I'm given the number of protons, and you'll notice my protons and electron numbers, because I'm balanced, are all the same. Okay? So if I look up number 37 on the periodic table, that's rubidium. If I look up number 35, that's bromine. And number 56 is barium. And number 34 is selenium. And number 24 is chromium, that shiny stuff on your car. All right. So what happens when I make these things into ions? Well, this is still rubidium because it has 37 protons. And this is still bromine because it has 35. And this is still barium because it has 56. And selenium because it has 34. And chromium because it has 24. How about charges? Well, here we have a positive, here we have a negative. And we have one more positive than we have negative, so I'm going to be positive 1. So I can write that as plus, or I can write that as 1 plus. Either way works. Here I have more negatives. I have one more negative, so that's going to be Br minus. How about barium? Barium, I have more positives, but this time I've got 2 more positives, so that's going to be a positive charge, but it's going to be a 2 plus, because I've got 2 more. Similarly, selenium is going to be a 2 minus, because I have 2 more electrons, I have more negatives. And here with chromium, I'm going to go towards the positive side because I've got 2 more positives. So that's going to be a 2 plus. Okay, here's our last slide. This is a little bit different than the rest because you'll notice that when we go from our balanced atoms, for example, we have number 23, which is a balanced let's try that again. A balanced atom on the left at 23. A balanced atom on the left, which is 33, which is arsenic, and number 32, which is germanium, and number 36, which is krypton. Now notice over here that I was not so kind. 24 is different than 23, so let's look at 24. 24 is chromium. And 33, all of our 33s are arsenic. Right, so I have to be kind of conscious about that. I have to make sure I don't mess you up here. And we have 3 more positives than we have negatives, so this is going to be a 3 plus charge. Here we have more negatives, so this is a 3 minus charge because our difference there is 3. But here we have more positives, so arsenic can take on a 3 minus charge or a 3 plus charge. In fact, if I look here, it's taking on 5 addition. It's lost 5 electrons, so this is going to be a 5 plus charge. Okay. Last slide here. You have to be able to tell by looking at something whether it's gaining or losing electrons. Well, electrons are negative, remember that. So it had to gain an electron to become negative. Here it had to lose an electron. Here it had to gain an electron. In fact, here it had to gain 3 electrons. And here it had to lose, and it lost 2 electrons. And finally here it lost 1 electron. Okay, folks, that's it. I will see you in class. If you have questions, come see me. Have a great day.